Hello everyone, welcome back. Today we'll discuss how Cursor AI actually works. So when you type code in Cursor, you are not talking to an autocomplete model. You are actually interacting with a distributed system that observes your intent, selects context under strict token limits, and orchestrates multiple AI models in real time. In the next few minutes, we'll break down exactly how Cursor AI works internally, from editor signals and embeddings to speculative decoding and safety layers. To make this easy to follow, we'll do this in a question answer format. Each question unpacking one layer of the system step by step. So let's start with the most basic question. What is cursor? So technically speaking, cursor is a fork of Visual Studio Code where AI is treated as a first class system component but not a plugin. Architecturally, cursor follows a client server model. The editor runs locally, collects signals, and managing the UI, while heavy AI computation such as retrieval, prompt construction, and model execution happens in the cloud. This separation allows cursor to stay fast locally while still using large and most powerful model remotely. So is cursor just VS Code plus GPT? A lot of people assume cursor is just VS Code with GPT bolted on it. But that's not true. VS Code was designed for humans typing code manually. Cursor is designed for humans collaborating with an AI in real time. This affects how context is collected, how changes are made, and how feedback is learned. So Cursor isn't a smarter autocomplete, it's just a different editing paradigm. So now let's just go to section 2, the problem that Cursor is solving. So when you code, a huge part of your effort goes into reconstructing context in your head. You are constantly asking questions like, where is this function used? What depends on this file? What style does this project follow? So Cursor tries to remove that mental burden. Its goal is to understand the context for you so that you can focus on decisions instead of navigations. So why does Cursor feel smarter than autocomplete? Traditional autocomplete only looks at the last few lines you typed. Cursor looks at your entire working environment. It sees your current file, related file, recent edits, cursor positions, and sometimes even your whole repository. That broader view is what makes Cursor feel intelligent. So now let's just go to the section 3, which is editor signals and intent. So what signals does Cursor observe from the editor? So Cursor instruments the editor very deeply. It doesn't just know what text exists, it knows how this text is being interacted with. It captures cursor position, selection ranges, recent edits, and diagnostics from the language server. These signals are combined into a structured representation of developer intent, but not just a raw text. Think of this as turning human interaction into a machine readable signals. So why is cursor pointer position is so important? The cursor pointer isn't just a blinking line. It's a very strong signal. If your cursor is inside a function, cursor AI assumes your intent is local to that function. If you select multiple lines, cursor AI assumes you want to modify or refactor that. Similarly, cursor position helps the system narrow down where your attention is actually focused on. So now how does cursor convert raw editor signals into intent? So cursor applies heuristics and temporal weighting to editor signals. Recent edits matter more than the older ones. Selected code matters more than the surrounding code. So for example, cursor pointer inside a function implies local intent. Similarly, multi-line selection implies transformation intent, while rapid edits imply exploratory behavior. This intent classification drives everything that follows. So now let's just jump into the section 4, which is context selection, which is actually one of the most important section. So why is context selection is the hardest part of the cursor. So large language model operate within strict context windows. So cursor must compress an entire repository, sometimes tens of thousands of lines, into a few thousand tokens. This becomes an optimization problem where too much content may lead to slow, noisy, and expensive responses, while too little context may lead to hallucinations. The intelligence of cursor largely lies in solving this constraint very efficiently. So, how does cursor choose what code to send to the model? Right? So cursor uses multiple signals to rank relevance. First, it follows static relationships like imports and symbol references. Then it layers in dynamic signals like recently edited files. Finally, it uses embedding similarity to retrieve semantically related code. Only the highest scoring chunks survive into the final prompt. So in this regard, what is token budgeting and why it is so critical? Cursor explicitly budgets token. Each context chunk has a cost, and cursor fills the budget with the most valuable chunks first. Lower valuable chunks are dropped entirely. This ensures the model always receives high signal context under even the tight constraints. Now let's just go to the section 5, which is code based indexing and such. So how is code base indexed internally? So cursor does not chunk code arbitrarily. It uses language parsers to build abstract syntax trees, which are ASTs. Function classes and logical blocks become indexing units. Indexing runs incrementally in the background, so only change files are reprocessed. This keeps the system responsive even for large repositories. So how are embeddings generated and used? So each code chunk is converted into vector embedding, a numerical representation. When a query comes, cursor embeds the query, performs a vector similarity search to retrieve the most semantically relevant code. This is a classical RAG pipeline which is technically adapted for the code. So now let's just see and check what's there in the section 6, which is model orchestration. So does cursor use multiple models internally to this? Yes. Cursor routes requests to different models. Small fast models to handle intent detection and quick recompletions. Larger models handle reasoning heavy tasks like refactors and multi-file edits. This architecture balances cost, latency, and quality. So what is speculative decoding and how does cursor use it? Speculative decoding is a very good latency optimization technique that is very prevalent and very popular within agents. So, a small and fast model generates a draft response here, while we keep a large model that verifies whether the generated things from the small model is correct or not. So, the draft is correct. Cursor can stream results almost instantly. If not, then the larger model takes over. This is one of the reasons why cursor feels very fast despite using large models. So how does streaming affect user experience? So cursor streams token as soon as they are generated. This reduces perceived latency the user sees and allows users to interrupt or guide the process mid-generation. So now let's just go to the section 7, which is safety, shadow workspace and validation, right? So cursor often applies AI generated changes in an isolated shared workspace. This allows it to detect syntax errors or failed checks before touching your real code base. It's a safety layer between AI output and the production code. So in this way, they manage if things are working fine or not and act as a validation layer. Now just jump to the section 8, which is feedback loops and adaptation. So you must have seen cursor starts following your way of writing code, right? So how does cursor actually use such feedback signals technically? So cursor measures how far AI output deviates from the human final edits. This edit distance sometimes becomes a feedback signal. So over time, cursor adapts suggestion to better match your coding style and preferences. Let's come to section 9, which is failure modes. Where do cursor's technical limits appear? So yeah, cursor still has some issues and failure modes. So cursor struggles when static signals are weak or intent is unclear. There are fundamental limits of context-based system, but those are not simple bugs. So the final section, why cursor is different. So what is the real technical innovation behind cursor? Cursor real innovation is not its model, it's the engineering. How context is selected, how latency is reduced, and how feedback loops adapt behavior. So cursor is not about replacing developers, it's about compressing the distance between human intent and executable code. So that's all I have today for cursor, like how it was, how it deep dive like internally. So thanks for watching. Hope you see you around. Thank you.